This mini lecture will discuss the concept of the compound pulley and how it affects calculations in a mechanical system. Typically, when we look at pulleys previously to this course, they performed a simple function. If you had a single pulley, their job was to take a force or a load that was suspended on one end of the pulley and use the pulley via a cable to change the angle of the force that was acting on that load. So this assumes that this is in static equilibrium, or if it's in dynamic equilibrium, we assume that the mass of the pulley is zero, so that we get the tension on the left and the tension on the right side of the pulley are the same. In this situation, this would be called a one-to-one mechanical advantage, meaning there is no mechanical advantage. The input force, one tension, equals the output force of the load, which is one tension. So the mechanical advantage, there's a theoretical mechanical advantage of a pulley system. It is either equal to n or n plus 1, where n is the number of pulleys. And all it requires is rewiring how you use your pulley, and you can increase your mechanical advantage by the number of pulleys plus 1. And so the mechanical advantage, remember, it is the force multiplier. It is the advantage of the system where you multiply that number by the input force to get the output force. It is also, there's a disadvantage with every pulley system. You have a distance multiplier that is the same as the mechanical advantage of output distance to get the input distance. So you have to put in, let's say your mechanical advantage is 4, you get 4 times the force output, but you have to put in 4 times the distance input in order to maintain conservation of energy. So if I take this pulley system, which has n equals 1, I get a mechanical advantage here of 1. That's not particularly useful. But if I just change it a little bit, let's suspend this load with a single pulley that's directly attached to the load. But run the pulley attached to the ceiling and around the bottom of the pulley, and then pull up on the load with our cable force tension T. Notice now that if I look at the pulley that is directly attached to the load, that there are in fact 2 cables, both with tension T, that pull up. And so here the tension equals the load, whereas here 2 tensions are actually going to be equivalent to the load, which means that you only have to put in 1/2 of the weight of the load and you can lift it. The disadvantage of this, though, is that if this load rises a distance s, you will have to pull with a distance 2s in order to use the pulley system. So this has a mechanical advantage here of 2-to-1, but we are still only using 1 pulley. If I go to the n equal 2 situation where we've got 2 pulleys. So if I suspend from the ceiling 2 pulleys, identical pulleys, one of which is directly attached to the ceiling and one of which is directly attached to my load. Depending on how I run my cable, I'm going to get a different mechanical advantage as an output. So if I run the cable like this, so if I pull down from the top pulley, run it around the movable block and back up to the stationary block, I'm pulling down with cable tension T. But if you follow this cable around, the cable tension is the same everywhere if we neglect the mass of the pulley, and if we count You literally just have to count. How many cables pull up on the load? Here, it's 2 to 1. So we get here a mechanical advantage with 2 pulleys of 2 to 1. That means that the input load, tension, is only going to have to be 1/2 of the actual load. So that's the advantage. We get twice the force output from the load, or we only have to lift with half the force in order to make this thing move. The disadvantage is, if this load is lifted with a displacement of S, we're going to have to pull on the end of this cable with a displacement of 2S in order to make it work. I can take the exact same pulley system. So we had 2 identical pulleys. One is connected to the ceiling, mounted, fixed. One is, so this is the known as the fixed or stationary block. One is directly attached to the load and it's going to move, so it's called the moving block or the traveling block. And if I just change the way in which I run my cable, if I run my cable like this, pull up on that pulley that's attached to the load, wrap it up around the stationary block pulley and back to the movable load, this cable tension is T, this cable tension is T, this cable tension is T, and if you add them up, the number of cables that are pulling directly up on this load is 3T. 3 tensions. So the mechanical advantage is 3, and 3 tensions is going to be equal to that load. So we get 3 times force multiplier output. We only have to put in 1/3 of the load to lift it. The disadvantage is, of course, if this load goes up a distance of S, displacement S, we're going to have to pull this with a displacement 3S in order to make it work. So this is essentially how you do this with the compound pulleys. The number of pulleys can change, but the mechanical advantage is either N or N plus 1, depending on how the cable is wound around the pulley system in particular.